Hi there, welcome to Chapter 12 Notes. This is the Part 2 notes for matrices. So starting off, we have a couple of types of matrices. We can have an inverse matrix. So we can calculate the inverse by doing A times A to the negative 1, which will equal 1's on angles and 0's on angles, which is also I, which we can use as the inverse matrix. If this has, we can use this to check if the matrix has inverse properties. If you don't get this kind of matrix, it doesn't have the inverse properties. Calculate the determinant of matrices. So for a 2 by 2 matrix, label them A, B, C, D, and we can work out the determinant if we follow this rule here. No inverse if the determinant equals 0, and also there is no solutions if the determinant equals 0. And this no solutions if the determinant equals 0, I'm going to go through what this means later when we talk about simultaneous matrices. We can place inverse matrix into our calculator. There's this whole function here to get it into your calculator, or a really quick easy way is just to put it to the power of -1. So you can go through this. Takes a long time. My advice is just to put it to the power of -1, because that's what inverse is to the power of -1. Now from chapter 11 we looked at how to display simultaneous equations as a matrix. Now looking at how to solve simultaneous equations using matrices. First off, you've got to check if the determinant equals 0, there is no solution. So that's from just before we mentioned about how to check for the determinant. If it equals 0, there are no solutions. So we want to make sure it does not equal 0. So we've got this formula here, AX equals C, and if we can rearrange this, we can find X by A to the -1, which is an inverse, times C. And I'll show you what these values actually mean, how we name the matrices. So here's an example. We've got x and y equals 2 and 2x plus 3y equals 1. So we can solve these simultaneously. Let's put this first into our 3 matrices. We have the values on the values on the variables. So 1 and 1 goes here, 2 and 3 go here. Then in our second matrix, we have our variables, x and y's, so vertically, x and y. And then we have our solutions, our answer to the 2 simultaneous equations, 2 and 1. We label these A, X and C. So we always need to label them in this order. Now to solve for X, now this is what we're doing here using these 2 formulas, is we are trying to solve for X. And what matrix X is our variables. So what we're trying to do is solve for the value of X and the value of Y. So if you're using this second equation here, A to the -1 times C, we can do our A matrix to the power of -1 times our C matrix. And the answer that comes out in this case, in this example, is 5 and -3. So these values represent the variables that were there, x and y, x and y. If we had 3 variables, so here's an example, just 2x plus 3y plus 2z. If we had 3 variables, we can do the same x, y, and z. Now, if in one of the simultaneous equations, for example, says 2x plus 2z, we've got 0y. So you actually still put in the value 0 into your matrix. So when you're doing your A matrix, you would just put 0 where that y did not exist. And you just continue to solve it like that. Transition matrices can use as a percentage or decimal value. Decimal is the more common, and then you can then convert into a percentage as you are moving through your calculations. So in this case, we read the top first, then we read the side. And it's very important that you understand when you read the top then the side, or when you read the side then the top. And how you can find out this is if we go to Compass, and under matrices, there's types of matrices picture here. Now that's from one of my board notes. So we've got dominance matrix, communication matrix, and transition matrix. Have a read of this. This tells you what you need to read. So for example, winner and loser there, from and to, and then we go from and to. So know when to read from the top to the side, or from the side to the top. So in this example, because we've got directional arrows on it, you need to specify that in your matrices. So for example, from B to C, so we go from the top, from B to C is 0.2 because it's 20%. So understanding how to read this, and remember we go from top to side. In this example, car was rented in and returned to. Once again, if we're given a value, for example, we had 100 cars, you can work out how many was, in this example, returned to, rented in and returned to. You can work out the exact value by just multiplying it by the percentage as a decimal. Recurrence relationships for matrices. So we've seen this back a few chapters ago, how to use recurrence relationships, and then the rule, the difference between what a recurrence and a rule is. We can do the same with matrices. So you might have a T matrix and an SN matrix. So you might have the value of the 7th matrix. You can work out what the 8th matrix is. Or you might be given a starting matrix such as an S0 matrix, and then you can work out future matrices. So you might want to work out the value of the matrix term. Now, what a steady state is it gets to a stage that the values of the matrix won't change. Now, to work out something that's a steady state, you've just got to predict very, very, very far in the future. So in terms of an n value, you might chuck in 100 or 150. Be very careful. Sometimes if your calculator has too much memory backed up in it and you put in 200, it may freeze your calculator, or it may actually just down the bottom right, the circle thinking button will go for quite a while. So to find a steady state is when after a certain amount of time, our matrix actually won't change values. So you can find that just by predicting a large number such as 100. And further recurrence and rules, here's just some examples. On the exam, if they're going to give you some recurrence or rules, they'll tell you what that recurrence or what that rule is in the question. But some examples here, some may be a subtract b also instead of a plus b, but same sort of process as these examples up here. So any further questions you can ask me in class or email me in regards to when and where to use further recurrence and rules. Thank you.